Hello everyone, this is Blender Guppy. Welcome to an update video for the Random Flow add-on and the Creative Flow add-on. So let's start with Creative Flow add-on. So there's only a slight change for this, and this is for the Grid Project and Quad Slice. So Grid Project and Quad Slice, this is synonymous or similar to Random Flow's very own Grid Project and Quad Slice. This is because these two operators actually originated from Cuber and then got transferred to Creative Flow when Ice Tools and Cuber became one. So these functionalities are actually from Creative Flow. But I changed it initially in Random Flow, and then the change got ported to Creative Flow. So Grid Project, and let's try this. Ingonize this face. So Grid Project, and just let's test this. And now it's exactly the same as Random Flow's Grid Project. We have the percentage here, which can limit the existence or birth of some lines depending on percentage, and you can randomize the seed. This is mainly useful for random flow because the topology is uh, related to the result of the randomization. Okay, so grid project. So the changes for this is the now when you use the tangent, it's gonna be there's not gonna be a wasted number for this like from before. So it's exactly gonna give you just the exact amount of tangent information for you to cycle through. And this is the same with quad slice. So now it acts kind of like grid project, a grid fill, I mean. But yeah, so it's much better now and it's much less confusing. So there are actually two directions here. So from before, grid project and quad slice are using just the single or the longest edge in the selected faces. So for example, this is the longest edge, so it will use that. Or this could be the longest edge. So right now, it's using all the edge directions. So we have direction of this, and this. So basically this and this is the same. And so they cancel each other out. And we only have, and also this and this is practically the same. So they cancel each other out. So we only have, in the end, only have two directions for the script to use, this and this, or this and this. So when you use quad slice, this is what happens. So it's much better now. Also, I think staggered shortcuts. Yeah. Also, it will now highlight the faces that are affected by the cut. So for example, if I select this and use quad slice, you can see that it highlighted those faces and leave the others alone. Because now you can directly, after the operation, you can directly use the randomization. Okay, so that's for Creative Flow, Grid Project, and Quad Slice, and we haven't changed this. 1.1, I think the old version. So you'll see something like 1.2 in the new version. Yeah, 1.2 because this is only a change for the Grid Project and Quad Slice. So we come over to Random Flow. There's a lot of change, and we go to the settings, simple view, and set faces the vertex group. So simple view, this is the original view of the random loop extrude and random panels, random axis extrude. So with simple view, it will remove some of the properties that are least used and hide them. So simple view, loop extrude, there you go. The one that's hidden is the individual loop number for the loops, or loop seed, the individual seed number for the loops. So hidden are the smooth curves and all that. So it makes it look simpler if you want that. Okay. So do this only if you're quite used to the add-on simple view. And we have inset faces to vertex group. So by this only works for random loop extrude and random panels. So when I use them like this, example, so I need the top faces to be, I need something to select the top faces to make it easier for me as well to select the side faces. So the only thing for that is to group this using the vertex group system. So if the old version of using materials is gone, and now we're using the vertex group. So if you use this, there will be some added processing for the two operators, random loop extrude and random panels. That means that they will slow down a bit if you're using this, because of course it's cycling through the vertices and figuring out what vertices to assign to the vertex group. So there's going to be a bit of slowdown if you use this, but certainly not that much. Okay, so if I use random panels, increase the depth, increasing the depth just for this example. So picking this vertex here, Shift G, vertex group. Now it selects all the faces on top. And if I want to select the faces on the sides, press 3 to go to face mode and press Ctrl I. Okay, so with this method, you can easily use this to assign materials for the top faces or the border faces. And also you can use this for if you want to UV the side faces. And this is also the same for random loop extrude. Go to vertex mode, pick a vertex from the top, Shift G, vertex group. And this also goes for the other um, loop extrudes as well. So going back to random panels and doing this, we can let's use a higher island size. So if I want to just select all the top faces to use the um, random panels again, I can just do that. Use that. Use there we go. So you can use, there are multiple uses for this. And you can also use this for this kind of method, which is layering the uh, panel effects. Okay, so let's see. Faces is 64. 16. And this is 64. Okay, so for the next settings, we have the face select limit. So basically, for every random operator that uses subdivision in their script, For example, random loom extrude, it uses here the cuts, the subdivision, and also here. They're all script subdivision, random panels, random axis extrude, scatter, no, cells, random cells, which is a new operator. So basically, what random cables, basically whatever that uses splitting or subdividing the faces that are selected falls with this settings here. So face select limit, if the faces that you have selected have gone past or equals 250, then have gone past 50, then the subdivision properties will default back to 0. For example, here, if I use this and use something like this, it doesn't. When it works, it doesn't prevent you from going higher with the subdivision. It works at the start of the operation. Okay, so 16. So 16 for this is 16, and we used 16 subdivision. And this is 64 faces. And the thing with the operators is that the last settings that you've used will be incorporated to the next operation you used. So let's try this. So with the settings on, this should probably work, and it will reset the subdivision to 0. So random panels 0. Okay, and this also works with random loop extrude. Uh, it defaults the subdivision cuts to 0, and also the loop subdivision cuts to 0, and all the operators that I mentioned earlier. And then we have UI change. So the mesh submenu is now gone. The contents of the mesh submenu is now in extras again. So apply mesh. Apply mesh is the same as creative flows. Apply mesh. And the and the data features, mesh data features is now exposed one layer up, and now it's exposed in the main menu. So extras, yeah. So from before it's in extras with cleanup and merge objects. Now it's exposed outside because this is an alternative to using extract faces. So for example, if you have a topology, this is for example our base topology or our source mesh, and we don't want to disturb the underlying topology or solution, then we can use extract faces to extract the faces that we need to use for the randomization. Edit this to codify or something. Yeah, and or add more loop cuts that, and then select everything and use randomization or the random operators. You can also use the mesh data for that. There's no extraction. This is used to save the state of the mesh as it is when you use the operator. So we're going to save this state, save, and then we can change the mesh. One slice, tangent select. Then we can select the faces that we want for the randomization. Use the randomization. Whoops. Okay. Now that you've finished with the topology, when you can use this in edit mode or in object mode. Let's try it in edit mode. So we saved the data from before. Now we can revert it back, we can use some of the mesh data that is saved. Use says here that found one matching geometry. So if it found more, the list will go on down, but the one that is closest to this geometry will be the one displayed at the top. So the one at the bottom is the least likely to be this mesh, and the one at the top is the more likely to be this mesh. So let's use this. Okay, so now we have our old mesh back, and this state is still saved in memory, but we can clear everything. When you use the clear operator, it will clear all the mesh data that you've saved. So just to be clear on that, so clear. You can see here, one saved mesh data removed. Okay, so you can either use extraction or this the data feature, which I think is pretty cool. I did spend time trying to code this, so when I saw it in extras, it's pretty much hidden. So I think I better expose it so people can use it more. So sometimes it's much more convenient than using extract faces. Extract faces, however, has some uses, especially with um, when doing asymmetrical collections. Okay, so that's with data. So let's start here. Random loop extrude. So random loop extrude and split. Wrap and split. So okay, so there we go. Walk and radial. So the last two has been changed. I think the last two was recursive and I forgot the other one. So it's recursive and the other one. So right now they've been reworked into a much simpler algorithm, which is walk. Now you have two, walk and radial. There will be more in the future, but since recursive and the other one looks exactly the same at most of the time, I've decided to just combine them to a single algorithm. So walk and radial. For future solvers, they must look very different from these two to be included in an update. So walk and radial is the same with random panels. Walk and radial also. So this determines the way uh, the script creates these lines, these cut lines. Okay. So with random loop extrude, and when using individual solver path, we have in solver. Now we only have one and two. One is walk, two is radial. From before, number three is radial, two is recursive, and number one is the other solver. So this only goes to one and two right now, and path is still this one, two, three, none inner and outer. One, two, three. Okay. And now we have the merge panel also, which works great if you're using the natural resolution of the model. Zero, we press merge. So it merges beautifully because they have the same topology. But if you use subdivision, and if it get merged, it will still merge, but you have this ingons at the borders, which you can manually fix if you like. Quad slice can help you. Blink faces. Okay, so random panels, wrap and split. I think wrap and split is also, yeah. Um, so split is the default from the other version, which is this one here, and wrap is used to be here. So right now the default is wrap, which means that the cut edges, the sharp edges, depending on the sharp edges, the cut angle right here, okay. Um, we'll try to wrap the islands on the sharp edges or hug it, but with split, it'll just split the sharp, the sharp edges, the angularly sharp edges, that not the mark, but also the mark sharp edges. You can use this technique to mark sharp some of the areas that are causing distortions, those spikes, the clear mark sharp. And yeah, random panels. Now we have random cells. So random cells is a quick way to recreate an effect which the random panels can do in a certain way, but random cells have exceeded, and that is to create just this tiny square noise, subdivided face noise. And if we add thickness to it, you can see it's done. So in my videos, you can see me use this to create random lights. So I am no longer limited to just textures, to using textures. I could just click on the geometry and use this and create those lights, those panel lights, and randomize their position like that. So it's a very simple operator. And we have the island size here. So this is basically the initial set of islands, and then you can make them larger. You can basically make them crawl like that, crawl to each other. And clear adjusted faces is to make sure that this doesn't happen, and every face is kind of like a single individual thing that the island size can still, of course, reach out, but the initial result will have each face have no neighbors. Okay, so we have our subdivision. This is also affected by the face select limit, island size, smooth. We have the smooth here for the cylinders, and we have the cut method, individual. If we increase the thickness, Oh, I used the operator twice. Okay, so increasing the thickness. If you set the cut method to individual, it will look like that. And we also have the offset to offset it off the mesh or to the mesh. And when you set the offset to individual, you get this effect. So when you're using individual plus individual, cut method individual and offset individual, this will of course affect the speed which the script works. So be careful about the full size and the subdivision. So play on a lower level, then slowly increase the play with the other properties in a lower subdivision level, then slowly increase the subdivision when you get to the values that you want. Sharp and sharp. So uh, zero offset. So this is oh, wait a minute. Offset. So individual. This is how I made those silly those antennas. And as also you can see that there's only one seed property to control everything. So I made it super simple. So you can use this for this antenna trick, and also that's poking out of the spaceship, and also in random panels, you can see we have. So for example, this is like a spaceship panel. So I can use this to set the sharp to shift the cut set the cut method to sharp and the thickness to something like this. Make it make the faces bigger. Check this off and increase the island size. You can use this to, on top of the panel effect, create some kind of noise to create some random details on the random panels. Some details that are sticking out. Maybe I should try another solver for this in the next version. Yeah, that's for the next version. So like that, you can also use nope sharp. So you can use it for that effect, the antenna effect, the lights, and also for other stuff as well, like spaceships coming out of a spaceport, something like that. So there's many uses for this. Oh, it's merged. I've forgotten to. I forgot to set this off. Okay, so random cells, random scatter, random tubes, random scatter. Let's see, cube mesh collections. So the changes for some of the operators have no visible cosmetic changes, only scripts wise to make them faster or something else. Random cables. Uh, Another feature for this will be in the next update after this. And we have the Final screws and flange couplings. Final screws. Now using panel screws in edit mode and using custom, the source object will no longer jump to object mode in the first use of this. So there we go. Margin, rad, uh, radius, and rotation speed. So it will no longer jump back to object mode. It will stay in edit mode. And we also have the mesh, the mesh. So basically this is the cylinder from before is now named basic. And we have the mesh, which now you can select a single mesh to use for your screw, to use as a screw. Oops, why did I model that? So model the screw with the screw detail on top. So the alignment the panel screw script uses is the Z axis. So model it standing up. Straight that way to make it obvious. All smooth. And so from before, without the mesh, you can use collections to assign a single mesh to this, but it's annoying. So Control G, then F9, assign it to a particular collection. Panel screws, go to collections, and then use this. So to avoid all those moves or all those steps, we'll just go and use mesh and use this. This is cylinder, mesh, cylinder, and the radius like that. Okay. When you create this, don't make it too small. If you select this mesh after then, so scale, and if we use the same mesh, oh, panel screws, cylinder, you can see that, oh my god, nothing, there's nothing. It's actually it's just pretty small. Look at that. So if no error occurred, that means it's there. So just increase the radius because this is actually um using the cube, the default cube size as a basis. So when you're modeling the cylinder or the screw, you can just scale it up something like that, but not too small. If it is too small, then you can just scale it up in the redo panel. Okay, so it goes. This is also true for. We have to create the cables first for flanges for the tubes. Random tubes. Increase the where's the cut? Are all these properties necessary? Yes. Are do I have to do you need to edit or modify all of the properties all the time? No. There are properties that are more frequently used, there are properties that are less used, and some are completely ignored. But are there so you can have control of them if necessary. Okay, where's the depth? So let's try that. So it's also the same with the Uh, Now you can use mesh for this, or pick a singular mesh for this. So the cylinder has also been renamed into basic. All smooth. So this is cylinder 1 as well. Straight on the cables. Mesh cylinder 1. There we go. And let's increase the count. Not too much. So in here as well. Actually, let's and mesh cylinder 1. There we go. Increase the radius. There you go. And yeah, so there we go. Now you can use the advantage of this is that you can easily use your imported uh, designs for the flanges and couplings and use it for your tubes or your cables. Okay, so next up, direct faces automated panel cloth. Yep, we're here. The panel cloth. Join objects. Also, join objects has been simplified and has been made better. Also, split mesh. And all the other changes are code wise or script wise and no cosmetic changes. So let's go to Final Cloth. Final Cloth, you won't see any changes because you need to increase the subdivision first. And the mesh starts out as either flat or smooth depending on the shading of the original or the source mesh. We can toggle the smooth shading here. So initially, this has object collision, and this can collide to source, and this is already, yeah, collide to source, and there's spinning. You can also disable pinning. Collide to source means it's colliding to the object where we selected the face at, and object collisions means it will collide to objects in the scene. But there's a way to trigger that, of course. So we have mass, which is how heavy the cloth is, pressure to create those puffy effects. And we have the shrink and the effects of gravity. Okay, we have bake frames for the how long you want the frames to bake or the physics to bake. So 20 frames. The higher this is, the slower the operation will become. So um, be mindful of that. So this is the default, and quality is the quality of the physics. This is the default quality. We can use 10. I mean, it stay at 5. And sometimes even use lower qualities because they look better. We have the margin, which is not related to any cloth physics. It just creates margin on the selected faces. We have the subdivision. The subdivision here resets to 0 every time because this is not the same as the other operators. And if you accidentally select like you used 16 subdivision for the single phase or 40, and when you have a setting of 50 here and you selected something like 16 number of phases and then use the panel cloth, and then this was not reset from the 40 value, then Blender will freeze. Okay? So just to extra security, it will revert back to 0 every time. But to avoid that, so you can use the setting every time on a single phase. You can save this preset here, uh, rename it to something that you can recognize. So fluff single phase. Okay. So panel cloth, we have cut 0, fluff single phase, fluff single phase. Okay. So that's how you can avoid the uh or use the operator faster by saving it as a preset, because the cuts will revert back to 0 every time to avoid freezing Blender. Okay, so let's use 30. Split mode, none. We have seam and angle. So let's divide this thing first. After I've released the update, there will be more videos where I'm using this. So panel plot, we have the seam and the angle. So we are using seam for the separate to split it into islands. So right now these are two different set of islands but a single object. So that can be done using seam, clear seam. It can also be done using limited zone angles. And when you select angle, you have the cut angle here. You can set. I just use the default 30 degrees all the time. So now they are cut via the sharp angles. If you choose none, it will use those three faces as a whole. So with angle, those are separated. Okay. Now we have pinning. So with pinning, with panel cloth, I'm using mark sharp edges instead of vertices because let me show you the if I for example use this, so for example vertex groups, assign this as a pin to pin the result of the panel cloth, but the of course the panel cloth is using subdivision. Okay, so here's what happens. And so vertex groups, Control G, select. Okay, that's our vertex group. So when you use the script and subdivide, for the cloth physics to work better, for with a lot of points to work with, the points being the vertices. But we select the group again. There you go. The group, the single vertex that is what that was assigned as initially to the group has, of course, multiplied and has along with the subdivision. And if that's being used for the panel cloth, then these are all going to be pin groups. and that's not what we want. So instead, I use the mark sharp edges. The only disadvantage is that you cannot mark sharp edge a vert because it is a vert. So, for example, this, we can pin this, mark sharp, 1 o'clock. There we go. This is not separated islands. This is a single island. And these areas are clamped or pinned. So to create pinning on the center, you have to do a bit of geometry trick. You have to actually uh, add more topology. Then we can use this mark sharp. There's no other way. I've looked up any other way to avoid the vertex group issue. There's no other way. So that we can use for pinning. So just increase the subdivision until you get a let's see if we can pin a square. Mark sharp. Select length, flat faces, and none. There we go. Oh no, there's a bit of distortion. You can figure this out. Just play with the. Maybe we shouldn't have. Or just use this one. Less sharp. Let's see. The distortion still happens, but think you can figure this out. But that's the only caveat with this is that the vertex group doesn't work well with subdivision when subdivision with a script, but using the pinning, using the mark sharp edges as the pinning, you can figure out some ways to work around the limitations. The remember the mark sharp is for pinning in the operation, and the mark sim is for separation. Okay, sim is for separation. Sharp is for pinning. After the panel cloth operation, you can just delete the mark sharp or seams that you have added in the um or before mark sharping or seaming, save the data like I showed you earlier. Limited dissolve. Okay, so panel cloth, and let's try with the physics. So I'm gonna tell you now. Also, the problem with Blender is that you can see this. This is a single phase, and it can go really far with the subdivision using this one. Doesn't matter. So 80, no problem. You can still work, kinda. There we go. It's still very fast, and this is how tiny those faces are this time. But the higher the base resolution becomes, the slower Blender will be able to work with it. Okay, so just remember that it's the same as the multi-resolution modifier used for sculpting. So the more basic your base mesh is, the more fluent you can work with multi-res. But the more developed or more detailed your base mesh is, the harder you can work with this. Maybe I'm wrong this because I haven't worked with this, but when the last time I've used this, that's the problem with Blender. They still haven't, I think, touched it because they're focusing on the topology, dynamic mesh, which is good. And so just remember that the higher the subdivision, the resolution that you've selected, the slower the physics will work, or and the other properties will work. Okay, so let's try with the cloud physics, gravity of 2. There we go. Let's try something like 3 to make it fast. Oh, oops, maybe not. 6. There we go. You can have that. And there's also that thing I showed you here. So this is from a cylinder, and this is the topology. I was finding it really hard to work with with a lot of resolution, base resolution, but I think I should have just worked on this segment here, then just arrayed to make it lighter, arrayed the other effects to make it lighter. So this is how it looks like with the procedural shaders. And cylinder, rotate it. If you want to play around with the with an operator, uh, use a new scene, empty a new scene, just and play around with it. So if it hangs or freezes, with your experimentations with the values, depending on your machine, of course, and the values that you're using, then yeah, use a new file, Control N, General. So we're going to use this for this type of effect. So we can't really use this because for the cloud physics to work beautifully, the base topology must be quads and they must be even. And also the if you select n-gons, the script will automatically quadify the result. Okay, so with this can probably slow our the this will probably slow the um operation. Panel cloth, yeah. And we need gravity. Let's just work on one and work on 20 frames, bake on 20 frames, and use gravity of 2. Maybe 1 is enough, but yeah. So initially, this collides to the source, so let's disable the collision to the source object. And yeah, I should have hidden that thing first. So we can go to wireframe to see the bending. Okay, so cuts. There we go. Actually, this looks okay. I'm not gonna dwell too much on the. Yeah, this looks okay. So it's having a really hard time. So just have patience, work on lower values, then slowly make your way up. There we go. A lot of those wrinkles. We need those wrinkles. Without those wrinkles, it's useless. The fractal is from the subdivision and the script. So mainly this is fractal noise, and normal means the fractal will extrude using the normal of the selected faces. Let's use that. And I've exposed this in orders because sometimes with weird angles of the faces, gravity and wind cannot produce the intended wrinkles, and you want those wrinkles. You can produce those wrinkles when you're using the fluffy method. It's going to always have those wrinkles in the sides, the borders. But sometimes if you're just using just a real flat effect, you can use the noise to coax some of the wrinkles uh, to appear. But it's not gonna work every time, of course. But it will work. It will surprise you uh, on what type of geometry it will work on. But I've exposed it to coax some of the uh, when there's really no wrinkles showing up. You can use this to coax some of it out. So what does this look like? The fractal. Control Z. This is what it looks like in the script. And this is our fractal. So this is fractal noise. Along normal, and this is the seed. So that's how it look like. It looks like. Okay, so hide this. So we have this. This is actually looking real good. You know what? Let's use this. Alt H F. Problem with this is that it's not quantified. So what do we do? Well, we'll just cleanse slice and fix the, yeah, there we go. Never mind the triangles and the sides. Panel cloth. I wonder if it looks okay. Oops. It just crashed. Recover last session. It's not it. Recover autosave. Wait. Nope. Oh no. Fluff test. Recover autosave. We've lost it. Last session. What the? Where's the? Sorry about that. It's a good thing I'm recording at full windows. I should have saved the. Anyways, that's the thing. You can use if you've ever encountered a n-gon, you can use grid project, for example. This projects a grid topology. This can create n-gons in the borders, but the script in panels will quantify that by using the triangulation plus quantification method. There we go. So the script will actually work, but it will of course not look nice. But if you're in a hurry and that detail is somewhat far away from the render angle, then you can use that. You can also use the um, quad slice like I've shown you before. So this will mostly result, depending on the topology, some triangles may result in the borders. So this is much better, I think. There we go. Oh, so let's retry the experiment. Control A, I mean, set origin to the cursor. Oh, set origin to geometry. Whoa, let's create a new one. So let's recreate the ones from before. We'll save. We finally saved. I think it's because of the simulation in the script that it crashed, but it very rarely crashes. When it crashes, it's Blender's fault, not the script. Okay, so let's use the what was the I think we used 4 for this. Too much shrinkage. Increase the maximum weight or mass. Weight is its margin. 0. And gravity is 2 by 2. And disable collision to source, collide to source. Increase the subdivision. Oops. Oh no, we're not getting the same result as the Wesley. Point minus 0.5. To use this effectively in the shrink, it must go towards the negative side, not the positive side. I'm still working out the positive side. A great use for the positive side because the positive side flaps or goes to the mesh, and you can't see that anymore. So yeah, I'm trying to find a way to uh, have a use for that. So mass is 2. Oh my god. What is our setting from before? 0.8. So this doesn't look like anything like the ones that we got before it crashed. Dang it. Pressure of 2. Ink. Oh no. Wait, one. Oh, there we go. It kind of looks like that. So I guess it's heavier if the mass is, I don't know. So this has actually other names, but I simplified the names for you because they just work in the same name in the same way as the words. So mass pressure. This is actually some low named differently in the clock settings. Okay, so let's use this one. Control save. Haha. And quad slice. The direction really doesn't matter. Oh, and yeah, you can use the panel cloth in object and edit mode. Sometimes I just go to edit mode because to object mode because from before the add-on doesn't work in edit mode, so I'm used to switching to object mode. So let's try and see what this develops. This kind of looks like a bag. I was having for a bag, but yeah, we get this. It's really cool. So you can create the fluff, and also for the let's create a new file for the collision. So initially, the collision works. The collision only works with whoops. The collision only works with the source object. Now you can toggle it off. Collision to source will come after this update. I'm going to study its effect first before uh, before putting it on this. Okay, so collision to source. But the way to activate the collision to other objects is that via selection. So this is our source object, the one that we're using the face of. And all you have to do to select the to activate the collision for other objects is select it. So select the other objects. The final object is the active object and is our source object, which has the face that we will use. Okay, so panel plot, none, and you can see the collision working there. Okay, you select it first, then the last one will be the source mesh where the face that you have selected is where the face you have selected is from. Okay, here you go. The settings of the collisions are here. Collision quality default is 2. Collision distance and collision clumping. This doesn't seem to show any change most of the time, but I just expose it because it's part of the primary settings. So when you disable this, you disable the collisions. You also disable the collision to source, even if it's toggled on. And also the properties for the collision quality, collision distance, collision clumping is hidden. Okay, there we go. You have the collection. The resulting mesh is real geometry, except for the subdivision that you have added using this one here. Subdivision, subsurface level will be here, will be reflected here. It will not be applied. It is for you to apply. Control A. Okay. And let's try it again, but on cursor selected and cylinder view like that. Select the cylinder first and then select the source mesh. Because the last one selected in Blender will be the active mesh first anyway. So this is the selection mechanism I'm talking to you about. So let's see if it's, there we go. It will not work on, sometimes it will not work on some configurations, but all you have to do is just move things around for it to work. So you can have that. So you have a a hallway panel that has a tube running, that has a part that has a tube running uh, to it, and you also have a cushion, but you can't really create a cushion without the. You can't really create effect like that because this will be clipping the cushion, so we can use the selection mechanism. Okay. So for the other, I may have forgotten some other properties that can be useful, but I have basically generalized everything, and I will expose other properties that I made them useful in the future. I've tested every properties and put them here and worked the work the script the panel to see if they provide any changes. No changes at all. The air viscosity, no change. The other property that lets you relax the hold, no effect. And which I wondered why there's there no effect. So I didn't include it for here first. So bake frames, remember, you can go to 50. So that's how long the bake animation can bake. But remember that the higher this is, the slower the operation becomes. Okay, so slowly play with the values until you get the ones that you need. So individual, last one is individual, I think. And let's use these four faces here. Let's separate using sim. Remember, separation is for sim, and pinning is for mark sharp edges. Okay, panel cloth and sim. Now, you can see that their wrinkles basically looks the same, but since we've separated them into their own individual islands, we can use this individual to make every every single face islands or every cushion, every cloth effect different from each other. Here we go. So individual means uniform changes. This only works if they are separated. If there's no separation, they won't work. Or if you use clear seam, mark sharp, because this is pinning, this is not actually separating the islands. If you use individual, you can say there's no result. This only works if the result of the final cloth has been split into separate islands, like this one here. Uh, limited dissolve. So let's go in. We're going to use split mode angle. So they look the same, but they're split, so we can use individual. And they're going to have a different look every time. Okay. So to avoid the randomization not working, then you can just use the same values for min and max. Like that. And if you play with the clock to the seed, you can see there's no change because min and max of these values ha, have the same of these properties have the same values. Okay. So I really like this panel cloth. And in the future, I will be adding physics with cables as well. I didn't add it at the last moment because there was some few components that I was missing to research. So next update after this, physics for the cables. So when you move it around, it will dance around because of the gravity. Okay, so that is it for this video. And I will put the update videos, I will put in a single playlist where you can watch in my YouTube channel. So for example, that you have missed a version, you can go to that the playlist link will be in the product page. You can go to the playlist and then look at the version number. So for example, 1.9 here, you can just go there and watch the video on what changes that occurred. Okay, so these are some of my earlier experiments when I was working. So I was also, it's a good thing that I can model, because if I can just script and not know how to work with Blender modeling, then it's gonna be a lot of work hiring somebody to actually use the script, and communication between the modeler and the coder can sometimes be confusing. Okay, so that is it for this video. I hope you learned something with this, and yeah, be sure to use this to their full advantage. And I will be releasing more videos to demonstrate their process. And also the PDF guide has been not updated for a while, so I will also update that before the next update. Before the next, hopefully for the next update of this of the add-on as well. Okay, so that's it for this video. If you have any questions, use the comment section and or the description of the video. And thank you for watching and have a nice day.